Hello everyone. We've learned about the real op-amp and built its circuit model based on its transfer characteristic. In the circuit model, there is an input resistor, an output resistor, and a voltage-controlled voltage source, which represent the relationship of the amplification between the output voltage and the voltage difference between the non-inverting input and the inverting input terminals. Since actual op-amp's input resistance is very large and the output resistance is very small, we can simplify the circuit model. If its input resistance tends to be infinity and output resistance tends to be zero, the circuit model can be simplified like this. Here I'd like to ask a question. What's a suitable value of the resistance in the external circuits? We can find the answer based on the order of magnitude of the input and output resistance. Op-amp's input resistance is usually with the order of magnitude of mega ohm, and the output resistance is with the order of magnitude of ohm. If we can regard the mega ohm input resistance as infinity and ohm output resistance as zero, obviously the resistance in the external circuit must be with the order of magnitude of kilo ohm. On one hand, if the resistance in the external circuit reaches the order of magnitude of megajoule, then because of the voltage division, we cannot regard the input resistance as infinity. On the other hand, if its order of magnitude reaches ohm, then also because of the voltage division, we cannot regard the output resistance as zero. You should notice this when constituting real circuits with op-amps. Based on this circuit model, if we simplify it further, by regarding the open loop gain as infinity, then we get an ideal op-amp. Pay attention please. The circuit symbol of the actual op-amp and the ideal op-amp have no difference. Have one difference. Here is the open loop gain and here's the infinity. Now let's study the ideal op-amp's characteristics. After the simplification and the approximation from a real op-amp, we still focus on the op-amp operating in the linear region. In the linear region, since A is infinite and output is finite, then UD equals 0. That is, U plus equals U minus. In other words, the non-inverting input and the inverting input are with the same potential, like short circuit. It's called the virtual short circuit. Secondly, since ideal op-amp's input resistance is infinite and the output resistance is zero, the current through the non-inverting input and the inverting input terminals should be zero. In other words, seeing from the non-inverting input or the inverting input terminal, the op-amp is look like the open circuit. It's called the virtual open circuit. Let's look at the ideal op-amp's transfer characteristic. It's an approximate transfer characteristic of the actual op-amp. For the ideal op-amp, the open loop voltage gain is infinite. When operating in linear region, its transfer characteristic should be the red polyline. When UD is larger than 0, the op-amp's output is positively saturated. When UD is less than 0, the op-amp is negatively saturated. Only when UD is 0, the ideal op-amp can operate in the linear region, which in fact means the first property, the virtual short circuit. After learning the two properties, the virtual short circuit and the virtual open circuit, we can analyze the negative feedback circuit with the ideal op-amp. You should notice that these two properties can only be satisfied when the ideal op-amp operates with the negative feedback in the linear region.